Hello, welcome to you all for the course Python Programming for Beginners. In this lecture, we will continue one of the Python open source library, that is NumPy. As part of NumPy library, here we will see introduction followed by how to install NumPy, then how to create arrays with NumPy with example demonstration will be discussed in this video. As we know, in our previous lecture, we already discussed the overview of various Python open source libraries for data processing, data modeling, and visualization purpose. So in this, one of the important library is NumPy, which stands for Numerical Python, which is an open source Python library mainly used in almost every field of science and engineering. It is the universal standard for working with numerical data in Python, and it is at the core of scientific Python and PyData ecosystem. What is PyData? A community for developers and users for open source data tools. So NumPy users include everyone from beginning coders to experienced research doing state-of-the-art scientific and industrial research and development. The NumPy application programming interface is mainly used extensively in Pandas, SciPy, Matplotlib, Scikit-learn, Scikit-image, and most other data science and scientific Python packages. The NumPy library mainly it contains multi-dimensional array and matrix data structures. It provides ND array, which stands for n-dimensional array, a homogeneous n-dimensional array object with methods to efficiently operate on it. NumPy can be used to perform a wide variety of mathematical operations on arrays. It adds powerful data structures to Python, which guarantees efficient calculations with arrays and matrices, and it supplies an enormous library of high-level mathematical functions that operate on these arrays and matrices. So NumPy can be easily interfaced with other Python packages and provides tools for integrating with other programming languages like C, C++. What are the advantages of NumPy? Fundamental package for scientific computing with Python, which is an n-dimensional array object, linear algebra, Fourier transform, random number capabilities are included. Building blocks for other packages like SciPy, which is a open source. These are all the advantages of NumPy library. Then how to install NumPy? To install NumPy, we strongly recommend using a scientific Python distribution. If we already have Python, simply we can install NumPy with the following statement: pip space install space NumPy. That means pip install NumPy. Here pip is a package manager for Python packages or modules. Suppose if you want to install NumPy library in Anaconda software, for that the statement is conda space install space NumPy. Here conda is a cross-platform package and environment manager that installs and manages conda packages from Anaconda repository as well as from Anaconda Cloud. These are all the two ways of installing NumPy library. Okay, by using official Python IDLE, how to install NumPy? Okay, you can click the Windows key on your keyboard, then you can type CMD, that means command prompt, then you can open, then the following terminal should be opened. There you can type pip space install space numpy. Here you can see, here we already entered pip space install space numpy, then you can simply enter. So then it should start the installation. After seeing the successful installation, again we have to go back to our IDLE and try importing NumPy. So now here we already installed. Here you may get one warning message. You can ignore. No problem. You can ignore this one. Now the installation is successful. Now you can go to your Python IDLE. Then you can check out. So how to check this one? For that, we have to use the statement. To access NumPy and its functions, we have to import our Python code using the following statement. Import space NumPy by creating one alias object for the NumPy using as space NP. Here NP is the alias or object of this NumPy module. Here we shorten the imported name to NP for better readability of code using NumPy. This is a widely adopted convention that we should follow so that anyone working with our code can easily understand this one. So now in our Python, ideally you can type import numpy as np. Whenever you can enter this one, again it enters into the prompt. So without any errors, that means the installation was successful. Anyway, during our program exhibitions, we will see this one. Okay, now how to work arrays with NumPy. A NumPy array, what it requires, which requires a much less memory to store the same amount of data compared to a Python list. It helps in reading, writing from the array in faster manner. So that is the advantage of NumPy whenever creating arrays. So what are the attributes of n-dimensional array object? So NumPy arrays class, we will call it as n-dimensional array, which is written as ND array. It is also known by alias array. So here you can see one difference. NumPy.array and the standard Python library class array.array both are not same. You can see NumPy.array using NumPy module. Already standard Python library class we are having. So that is array.array. These two are not equal. The reason here you can see. So this array.array, which handles only one-dimensional array, and offers less functionality. That's why these both are different. Then there are more important attributes of an ND array object. So the first one is NDArray dot NDIM. So that means if you want to find the dimensionality, the number of axes means dimensions of the array, will use NDArray dot NDIM. Then you want to find the shape of the n-dimensional array. The method is NDArray dot shape. So here the dimension of the array. This is a tuple of integers indicating the size of the array in each dimension. That means row column wise. For example, if you can take matrix with n rows, m columns, then the shape or dimension will be n comma m. That means n by m. Here n is rows and m is column. Okay, then the length of the shape tuple is therefore the number of axes. That is n dimensionality, n DAM. The next attribute of ND array object is size. So ND array dot size, which is the total number of elements of that particular array. This is equal to the product of the elements of shape. Then the type of array for that ND array dot D type. So an object describing the type of the elements in the array. One can create or specify D types using standard Python type. Additionally, NumPy provides its own type. For example, numpy.int32, numpy.int16, and numpy.float64. These are all some of the own types representation. Then you can find the item size also. The next attribute is item size, which is denoted as ndarray.item size. Here the size in bytes of each element of the array. For example, an array of elements of type float64, which has item size 8. How it can be calculated? So that is here total float64 means 64 by here 8 we have to take. Why? Because this is the standard one. Then for example, complex type with 32, then item size equal to 32 by 8. So here 4. It is equivalent to ndarray dot d type dot item size. Then you can see the data. What are the actual elements are presented in the array? That is denoted with ndarray dot data. Here the buffer containing the actual elements of array. Normally we won't need to use this attribute because we will access the elements in an array using indexing. Then let us come to example demonstrations in Python how to create an array. First, to create a NumPy array, we can use the function np.array. So we need to create a simple array and we have to pass a list to it. So if we choose to, we can also specify the type of data in our list. For example, the following example, let us see. Here, this is Python IDLE shell script 3.10.0 version, whatever the current version you are using. So here first we have to import NumPy, then creating the object as NP, then creating an array with the method what we mentioned np.array. So np.array, then you can pass a list to it. Here the list with 3 elements 1, 2, 3 we are passing. That result is stored in the variable a. Simply then you can call a, what you will get with type array. What is the list here? 1, 2, 3. So 1, 2, 3 as it is we will get. So let us come to our Python IDLE and let us check. Okay, can open the Python IDLE, whatever the Python software you are having. First, what you have to do? Import NumPy, create the object as NP. Now here again the prompt is entered means no error. So NumPy is imported. Now create an array and that can be stored in the variable a np dot array. What we are doing? We are passing a list with elements. Suppose 1, 2, 3, 4. Take 4 elements. Then close the list. Then close the array function. Now you can see here it is created. Now you want to see the result which can be stored in the variable a. Simply you can call a. Now you can see with array, it is prefixed with array, means array type. So what it contains? The list. What list contains the elements? 1, 2, 3, 4. Like that we will create an array and we can pass a list to it. Then coming to next one, we can pass particular elements to array also. So here if you want to pass zeros, if you want to pass ones, separately we are having the methods. So here the first one is creating an array from a sequence of elements. We can easily create an array and filled with zeros. By default, all the elements are zeros you want to fill. For that, we are having zeros method or function. So with numpy object np dot zeros. Suppose here we mention the value 2 means 2 zeros. It's filled with 2 zeros. Here you can see 0, 0. By default, it takes the floating point 0 point. So after that, by default, nothing will be there, blank. So array of 0 point, comma 0 point, 2 elements. Suppose you can take even dimensionality also. So np dot zeros, here you can see 3 comma 4. So what is meaning of 3 here? 3 is nothing but row, 4 is nothing but columns. So 3 rows, 4 columns. Then the matrix dimension is 3 by 4. Here you can see this is row 1, row 2, row 3. Then 4 columns. Here you can see column 1, column 2, column 3, column 4. If you can see the matrix wise like this, otherwise here you can see the list. So here 3 lists, here you can see this is list 1, this is list 2, this is list 3. Every list 4 elements. Here you can see 1, 2, 3, 4 with all zeros 0 point, 0 point, 0 point, 0 point, 1, 2, 3, 4. This is list 1. Again list 2, 1, 2, 3, 4. Again list 3, 1, 2, 3, 4. Here you can see with the 2 perspective you can express this one. But here you can see 3 comma 4 means it is generating lists. Why? Because here it is separated with comma. If no comma is there means then that is matrix. You may consider it as matrix. So like this. So here all zeros, 3 lists, each list 4 elements. By default, all are filled with zeros only. Now let us demonstrate if you want this one. So here you can see simply instead of storing directly also you can use np zeros of, for example, 2 zeros you want to fill. The array filled with 2 zeros. So you want to fill with any number of zeros. For example, filled with 5 zeros. Here you can see. Now you want to take the dimension. For example, 2 by 4. What is meaning of these? 2 list, then each list 4 elements. You are getting error. So what is the problem? Let us see here. Here you can see the list elements again you can pass as a list. Another set of braces you can use. Array is zeros is the function. Inside function again you can take. Now you can see. So list 1, 4 zeros, 1, 2, 3, 4. List 2, 4 zeros, 2 comma 4, like this. You can fill with zeros. Similarly, we have to fill default with all ones also. We have the method ones, an array filled with ones, same as zeros. Simply you can, zeros is replaced with 1. Suppose here 2 ones you want to fill. Suppose np dot ones of 2. So now the output is array of 1 point, comma 1 point. So 2 ones. Even here you can see similar to previous one, with the dimensionality also you can provide, even type also you can provide. For example, here np dot ones of 2 comma 3 comma 4. So what is the meaning of this? Let us see. Here the first one is number of lists. The second one, the second element, what it represents. So number of, here you can see number of, here you can see total, this is list 1, this is list 2, this is the first one, 2 lists. The next one, what it contains, here you can see again the sub list. Here you can see this is each list 1 2 3, then again next list 1 2 3. Then how many elements? 4 elements. Here you can see 1 2 3 4. Each list 4 elements. Like nested lists are nested here. Here you can see the first one globally 2 lists. So here you can see this is one list, this is another list. Here you can see this is global. So list 1, list 2. Again you are creating each list 3 sublist. Here you can see this is 1 2 3. Again second list 3. This is 3. Then each list, how many ones? 4 ones. Here you can see 1 2 3 4, 1 2 3 4, 1 2 3 4. So 4 elements in each sublist. So which elements are added here? By default we are using ones method, so you will get default ones only. So like that, even you can specify here the type of array. Here d type equal to np dot int float, we are specifying. So then integer values, all are integer values. So that's why in the output also you can see, because of this, here the d type also displayed, whatever is specified same is displayed here. So like that you can create an array and filled with ones. If you want, let us demonstrate this program. Let us see, this code already copied here. Here an array with filled with ones with 2 3 4, 2 lists, 3 sublists and 4 elements, and type also have given int 16. Let us see. Here you can say I copied this statement, np dot ones of 2 comma 3 comma 4, d type equal to np dot int 16. Let us run this one. Here you can see np dot ones of 2 comma 3 comma 4, d type equal to np dot int float. Here you can see 2 main lists, then each list 3 sublists, each list 4 elements. Then the type what you have given, d type equal to np dot int 16. Here it is displayed the same, d type equal to int of 16. So like that you can define our own type also, int 16, int 32. So like whatever the types we want. Then even you can create an empty array also. How to create an empty array? The function empty creates an array whose initial contents is random. That means it won't take a fixed value. Randomly it takes the some of the values that depends on the memory, depends on the state of the memory. The reason to use empty instead of zeros, which is somewhat similar to zero, what is the reason? To increase the speed. Just make sure to fill every element afterwards. That is the intention. So by importing numpy array, then using the empty method, whichever the elements you want, mention the count. For example, the following statement np.empty of 2. That means the array with 2 elements. Here 2 elements means the values are random values. Every time the values are changed. That depends on the memory of the system you are using. For example, let us see in our system what you will get with the same code. So now we are here np.empty, empty of, for example, let us take 3. Here you can see the random values 1.01 e power minus 259, comma 6.03 e power 247, then comma 3.947 e power 180. So the random values that depends on the memory of the system. Suppose let us change the number of values elements. For example, here I have given 2. So 2, 0, 0. So that depends on the memory. Suppose you can take 1. Here you can see 0 point, only 1. Now you can let us see 3. Here you can see earlier whatever you got. Why? Because we are using one system. Once it is executed, the same value. You can close your browser again. You can redo the same. The values are not same. That's why that depends on the system memory. So like that, you can create even our empty array also. So another example, even different lists with different elements. Suppose here np.empty of 2 comma 3. 2 lists, each list 3 elements. Here you can see this is list 1, this is list 2. Each list 1, 2, 3 elements. Second list also 1, 2, 3 elements. See the random values here. That depends on the memory. So let us try this statement also. Suppose here np.array of 2 comma 3. So again here why the error means empty is a function. Inside function again we can create the sequence of the elements. I mean the what is the dimensionality you are given. Here you can see np.empty of 2 comma 3. 2 lists, each list 3 elements. Here this is list 1. How many elements are there? 3. 1, 2, 3. Here you can see the values are 1.39, something different values. Then second list also you are getting the same value. That depends on the system memory. Sometimes same, sometimes different. These are all just instead of blank, something is there. So that is the empty array. We have to create an empty array. Randomly, it takes the values. That depends on the memory. Then we can create an array even by specifying the range. So create an array with a range of elements. So to create a sequence of numbers, then what NumPy provides? The range is defined by using the function array range, which is written as array range function, which is similar to Python built-in range, but it returns the type is array here. Let us see one example. First, as usual, import NumPy package, then np.arange of 4. That means here by default 4 elements, those are all added to the array starting with 0 to the last but 1. It won't take the last element, won't take 4. before 4 starts with 0. The range starts with 0. That means 0, 1, 2, 3. The count is 4. 4 elements. So it excludes the last value because it is starting with 0. That's why here you are getting np dot a range of 4 means with array type 0, 1, 2, 3. Suppose here even you can give the step value, increment value. For example, the next example is np dot a range of 10, 30. Starting value is 10, the end value is 30, but it won't include the end value. But the step value is 5, increment value or decrement. Step value is 5. Now starting with 10, next 10 plus 5 equal to 15 is the second one. Next 15 plus 5 equal to 20 is the next third one. 20 plus 5 equal to 25. Now you can see 1, 2, 3, 4, but it won't include 30. It stops before 30. Now you can see 10, 15, 20, 25 like that. Next, another example you can see, even it accepts floating arguments. So np dot a range of 0, 2, the step value is 0.3, the increment value. So here 0 point, then plus the step value 0.3. Here you will get again for 0.3 plus 0.3, you will get 0.6. For 0.6, the step value is 0.3, 0.9 plus 0.3, 1.2 plus 0.3, 1.5 plus 0.3, 1.8. See the last value, it won't take 2. Before 2, what is the last value? 1.8 only. That's why it stops here. So like that, using range function also, we can create an array with a range of elements using the method aRange. So if you want, let us execute these examples also. Here you can say already these examples are copied here. Let us copy paste. So we already imported once. The ideal is opened. Whenever the ideal is closed, again you have to import. Okay, now suppose here np dot a range of 4. Come to your ideally. Here you can see. So the range with 4 elements. So by default start with 0, 0, 1, 2, 3. Total 4 elements are there. The next one, by giving step value, that is increment value, that is starting and end range. Here what you will get 10 with step value 5 and before 30, whatever the last value, that is 25. 10, 15, 20, 25. The next example, even by taking floating point values, which takes floating point values. Here you can see starting value is 0, end value is 2, means it won't take 2 before 2. It ends. The step value is 0.3, 0, 0.3, 0.6 and so on 1.8 in the last one. Then even this is another example. Here starting value is 2, end value is 9, the step value is 2, increment. 2 plus 4, 2, 4 plus 2, 6, 6 plus 2, 8. It won't take 8 plus 2, 11, 10. Why? Because the last value is 9, before 9, 8 is the last one. So that's why by creating an array, what it contains a range of evenly specified intervals. To do this, what we have to do? We have to specify first number, last number, and the step size. This is the first one. This is the last one. This is the step size. Evenly, if you want to provide the range, we have to provide the first value, last value, and step size. Then there is another method. We can also use np dot lin space. So what is lin space here? Space linearly spaced in a specified interval. We can also use np dot lin space, means linearly spaced, to create an array with values that are specified linearly in a specified interval. So as usual, you can import numpy here, np dot lin space, remaining everything same. Here starting value is 0, ending value is 10, then the step value number equal to 5. So number equal to 5 means total elements 1, 2, 3, 4, 5. 5 elements. So by default, it takes linearly incremental value. Here, for example, here you can see what it is. It has considered 0 point, then 2.5, then 5.5. What is the difference here? 2.5. So 2.5 is the difference. That means like quarterly. Quadrants, we will call it as first quadrant, third quadrant, like by default it takes. Then 5 point, then 7.5, then 10. That's why linearly it takes the specified interval. So another example, let us see here, starting value is 0, end value is 2. So then total 9 elements. So it is separating with 0, 0 0.25, 0 0.5. So 0.25 is the difference here. 0.75, then 1, 1.25, 1.5. This is 25 quartile. So like that it takes linearly. So here also same, 25. So like that, by using LIN space method, create an array with the value specified linearly in a specified interval. So if you want, let us demonstrate this one. Here the examples already copied. Range of evenly specified intervals with LIN space. This is the statement what we have seen. Here you can see. So np dot lin space of 0, 10, number equal to 5, 5 elements. So linearly with 0.25 difference. This is the array created. This we already. Next, another example. Here you can see np dot lin space of 0, 2, 9. Total 9 elements. The array with 9 elements, starting value is 0, end value is 2. So then linearly the incremental value is 0.25, 25% quartile. Next, even you can specify our data type. Earlier we already seen this one. Specifying your data type, while the default data type is floating point, that is np.float64. We can explicitly specify which data type we want to use. By using the dtype keyword, you can specify. So import numpy as np, this you already know. np.ones, for example, here two elements with data type dtype equal to, using the method dtype equal to np.int64. By default actually float, you want to specify other than that, so we are specifying int. And when that result is stored in x, then whenever you can call x, what will get? Integer values 1, 1. Then the data type also displayed 64. So another one that is filled with 1, then zeros you can take np dot zeros 2, d type equal to np dot int. Then that is stored in y. Whenever you can call y 0, 0, the type is 64. Let us see this one. So specifying our data type. So this is the statement what we have seen. Let us run this one. So np dot one sub 2 with d type equal to np dot int 64. Then call x here. Here you can see the type is displayed here. So even directly you can check this one. D type of x you won't get. So directly x dot d ty p. Directly you want to see this one. In the declaration we have to use d type. The same is displayed in our output. Array followed by its type. Suppose the same array without specifying d type as int, let us check what you will get here. Directly you can't create this one using the object np dot. Here you can see by default we are getting here. You want to specify the type explicitly also you can specify. Otherwise by default also it considers. Here we have specified. Even you can specify complex also. Let us see one example with the complex type. Here you can see np dot array of two lists are considered 1, 2, 3, 4. D type equal to complex. Now the elements are with the complex combination. Let us call A, that is stored in A. Here you can see the list one, two elements, 1 plus 0.j, 2 plus 0.j with this combination. Then 3, 4, 3 plus 0.j, then 4 plus 0.j. Here the first list 1, 2 converted into complex numbers. Second list 3, 4 converted into complex numbers. Why? Because here we have given type as complex. Another example, let us see. Without specifying type explicitly, you want to check the type. For example, one array np dot array of 1 to 3 list. So let us call x array of 1 to 3. You want to see the type of x. Earlier we tried this one actually. So you can use this method. The array variable resultant variable dot d type. Now what is the type of x? We know array, but you want to see. Here you can see x dot d type. You will get d type of, what is its type? Int with 32. This is the type used here. So like that you can check the type of array also. So another example, let us see. Here we are creating array with floating point values. Actually here what is the type you will get? Float. So here y dot d type. Let us see here. So here the type of y equal to float 64. So like that, without specifying the type explicitly, whatever the array we created using d type method, even we can find the type of array. These are all the examples what we demonstrated. Then even you can transform sequences of sequences into two-dimensional array, three-dimensional array, etc. Suppose here we have two lists here. Let us see here. So how to transform sequences of sequences into two-dimensional array, into three-dimensional array, and so on. Suppose array transforms sequences of sequences into two-dimensional array, then sequences of sequences into three-dimensional array. So that means suppose sequence 1, sequence 2, which is a two-dimensional array. Then sequence 1, sequence 2, sequence 3 into three-dimensional array and so on like that. So the following example, let us see. First we are importing numpy np.array. Here you can see this is sequence 1, sequence 2, means list 1, list 2. So now this will be converted into two-dimensional array. Here you can see. Yeah, this is 1, this is 1. Actually two lists. This we will call it as two-dimensional array. If you can take three sequences, then that is three-dimensional array. If you want, let us run this one. And this is the example what we demonstrated. Let us run and check. Here you can see z equal to np.array of the first list 1.5, 2.5, 3. That is one sequence. Another one 4, 5, 6. Here you can see these are all lists actually. We are taking it as a sequence 1, sequence 2. Now it creates into two-dimensional array. Here you can see this is one, this is another one. If you can take three sequences, sequence 1, sequence 2, sequence 3, then you will get three-dimensional array. Let us execute this one. For example, store in W. Let us take another sequence. Now three sequences. Suppose here 7, 8, 9. Now here you can see the output that is stored in W, called W. Now you can see this is three-dimensional array. Like that, sequences are converted into dimensions. Two sequences, two dimensions. Three sequences, three dimensions. Four sequences, four dimensions, and so on. Like that, it transforms. Okay, these are all some of the basics of NumPy. While creating array with various examples we demonstrated. In upcoming lecture, we will see some more topics on NumPy with respect to array operations. Till then, stay tuned for latest updates.